So now we are here. We're gonna the focus of this lesson, which is our third lesson, is going to be on haloalkanes. Some people call this alkyl halides. So it's the same thing. Alkyl halides or haloalkanes if you'd like, and alcohols. So I think to start off our discussion, let us define what we mean when we talk about a haloalkane. So a haloalkane, we're talking about those alkanes containing one or more halogen substituents. So remember, what are our halogens? So you should be familiar with them. So when we talk about halogens, we can be talking about fluorine, chlorine. You find them in the group 7 in your periodic table, bromine or bromine, and then what's the other one? Iodine or iodine. Doesn't I don't know how you pronounce it. Okay, so now we know that is an alkane. We've already spoken about what alkanes are, and then on that alkane chain, you might actually find one or two of these halogens, right? It can either be fluorine or fluorine or any of this, right? Okay, cool. So let us, not waste time and just take an example. So let us take, for example, if we had an alkane like propane, right? And then, and then let's say on this carbon here, we connect a chlorine atom. And then so if it was just like this, we were gonna start our numbering closest to the chlorine, because it's more electronegative. So let us say we start numbering 1, 2, 3, right? So what do you think our structure? What would be the structure for the name for this structure? So we would say, okay, our substituent is chlorine, and if our substituent, and that's actually something that I should have mentioned before. So if our substituent is fluorine or fluorine, depending how you pronounce it. So if it's fluorine, we say fluoro. How do you write that? And then if it's chlorine, we say chloro. If it's bromine, Br, we say bromo. And then if it's iodine, we say iodo, right? No, I'm just remembering my physics teacher in high school. He used to like saying iodo. So yeah. Anyway, so because our substituent in this case is chlorine, that means we would say chloro. And what's the position of that chlorine? It's 1. So we say 1 dash chloro. So between a letter and a number, you always include a what you call a dash, a number and a letter. But if it's between numbers themselves, you include a comma. So that is some of the things to take note of. All right. So now we say that it's 1 chloro. We know because it's an alkane and it has how many carbon atoms? It has 3. So meaning it's propane. So our name for this compound will be 1 chloropropane. So they're quite simple to name, right? Okay, so now let us move on to a different molecule. Still talking about haloalkanes. We haven't gotten to alcohols. So we'll take maybe the same thing. Let me see. We have C there, and then just still the same. It's propane, but now our chlorine is actually on the second carbon. Okay, so it's on the second carbon. We can either start numbering from this side or this side. Doesn't matter because our substituent would still fall on carbon number 2, right? So we have 1, 2, 3. So remember, it's to number them. It's just to ensure that your substituents have the lowest numbers possible. And also when we number them, you also have to make sure that you start the carbon number 1 is the carbon closest to your functional group, like we've described in the previous lessons, right? So now let us name this. So still gonna be the same thing. If you have your chlorine atom, where is it? It's on carbon number 2, so it's going to be 2 dash chloro. And then this structure is propane because it has 3 carbon atoms, so it's going to be chloropropane. So remember, we're talking about haloalkanes, which are alkanes with a halogen substituent. So it doesn't always have to be chlorine. It can either be fluorine or bromine or iodine. I'm just using chlorine as an example. Let us take another one where we have perhaps the structure looks something like this, and you can also just try to name it before I do. So there we are. And then let us say here we had an alkyne substituent. In this case it was methyl, and then there we are, and then we had that chlorine over there, our halogen. So it's a haloalkane. And we actually also in addition to halogen, we also have an alkyl substituent, and in this case it is methyl, right? Cool. So now it really doesn't matter our longest chain. It's from this side, so you can say 1 2 3. Another person might say 1 2 3. It will still be our longest chain, right? And then we start. So we said so before I move on, so you noticing two things. We have two substituents. The other one is halogen, and the other one is your methyl. So in terms of naming, which one do you think we're gonna start with? So this one is going to be chloro, right? And this one is going to be methyl. So if we have a case like this, you actually use alphabetical order. You start with the one in terms of ascending in terms of alphabetical order, so A to Z. So this one, C comes before M, right? So it means that we're actually gonna start with chloro before we move on to, what is it? Methyl. So you're gonna say that chlorine atom is connected to carbon number, is bonded to carbon number 2. So it's going to be 2 dash chloro, another dash 2, because we want to also include the methyl, which is our alkyl substituent. So it's going to be 2 dash methyl, right? And then the longest chain, we said it is propane. So the name for this thing is actually going to be 2 chloro 2 methyl propane. C comes before M in terms of how do you actually now organize your substituents if you have more than one. So it's just a matter of organizing them in alphabetical order. So when we do this, remember sometimes you can have a 2 methyl thing. Let's say you have two methyl substituents. So it means it's going to be it's going to be dimethyl. So this doesn't matter. So you don't actually consider the D, you just consider the name. So if maybe we had 2 substituent of methyl, it will still be 2 chloro, maybe let's say 3 dimethyl, because we don't consider the di or the tri in terms of organizing them in ascending order according to alphabetically, right? I hope that is making sense. So now, what else did I want to mention before moving on? I'm thinking. Okay, so the other important thing is that you should be able to identify what we call primary, secondary, and tertiary, what do you call this one? Tertiary haloalkanes. So let's go back. If you look at this particular structure here, you're gonna note something. And the thing that you're going to note is that the carbon bonded to your chlorine is bonded to one other carbon. So this carbon bonded to chlorine is bonded to one other carbon. And if that's the case, we call this a primary haloalkane. Now, let us look at this one here. We see the carbon, which is carbon number 2, which is bonded to the chlorine atom, is actually bonded to 2 other carbon atoms. right? I hope you can see that. And we call this secondary haloalkane. But now let us move on to this one. The carbon, which is carbon number 2, bonded to your chlorine atom, this carbon is bonded to 3 other atoms. So, and this one we call your tertiary haloalkane. So make sure you are able to identify them, you know. So that is an important thing. So now we've talking about haloalkanes. Let us move our discussion to alcohols. Okay, so now we're moving our discussion to alcohols. What are alcohols? How do you define alcohols? Think about it. What's your definition of alcohols? Remember, they're still organic molecules. So remember, with alcohols, we have something called the hydroxyl group. Hydroxyl, which is OH group. And that hydroxyl group is actually bonded to what we call is a saturated carbon atom. So it's single bonded towards with a, so we have a carbon and then there's a single bond between it and the OH group. And that's what we call alcohols. So that's the difference. So it's the functional group alcohols, they have the properties that they have, that hydroxyl OH group. And when we name them, our what is it? Our suffix at the end, we actually have to include all. And you'll see what I mean just now, right? So let us take a few examples. I'm trying to wipe this. Just take a few examples. So let us start with maybe this type of alcohol. So it has 3 carbon atoms to it, and I'm sure you can already tell what is it going to be. And then you'll have your H, 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 H. So somebody might already be able to tell me what it is. So we see, okay, how many carbon atoms do we have? It's 3, so we know that is their thing is going to be propan. The suffix is going to be propan, right? Okay, cool. And then we're gonna start numbering. Our carbon number 1 is going to be the carbon closest to our functional group OH. So that carbon closest to it, obviously, it's this one. So it's going to be 1, 2. So 1, 2, 3, right? So our OH group is at carbon number 1, so it's going to be propan 1. Because it's an alcohol, and I did mention it ends with all, so it's going to be propan 1 all. But because it's at carbon number 1, we normally don't write it. We can just say it is propanol. Okay, cool. Let us take another example. So let us say in this case, it was still the same 3 atoms, but now your OH group was here. So, sometimes I write it as OH, but it's a structural formula, so we must show all the bonds there. There is just a mistake. And then include your hydrogens. 1, 2, 3, 4. Okay, cool, right? So now it really so this is our functional group. It's an alcohol hydroxyl. So meaning the carbon number 1 will be the carbon closest to our functional group. And you see both of them are closest to it. So it doesn't really matter whether we say this is 1 or this is 1. So I'll start with say 1 is this one, 2, 3. And let us now name it, right? So in this case, we would say, okay, there are 3 carbon atoms, so we know it's going to be propan. If it was 4 carbon atoms, it would be butan, right? But where is the hydroxyl group thing? It's bonded to carbon number 2, so it's going to be propan 2. Because it's an alcohol, it will end with OL, all. So this is actually going to be propan 2 all. let us take another example, our last example. So we say still the same thing, and then let us put a methyl group here, right? And then we have your OH, and then there we are. All right, so we start numbering 1, 2, 3, right? And this becomes our methyl group. And then we also have your OH, your hydroxyl substituent. So how do we name this? So we know we're going to say it is 2 methyl 2 dash methyl to make to accommodate our methyl group. Because it's 3 carbon atoms, it's going to be propan. But now where is the position of the OH group? It's at carbon number 2 as well. It's an alcohol, so it will end with all. So we have 2 methyl propan 2 all. And the same dance that we did before with haloalkanes, we also have to know how to identify primary, secondary, and tertiary alcohols. Same thing, it's a primary alcohol. Why? Because the carbon bonded to our hydroxyl group, which is OH, is bonded to one other carbon. So this will be your primary alcohol. Here, the carbon bonded to our hydroxyl group or our OH group is bonded to 2 other carbons. So this carbon is bonded to this carbon and this carbon. So it is our secondary alcohol. And now if we do the last one, tertiary, this carbon here, which is bonded to our hydroxyl group OH, is bonded. So this carbon is bonded to this carbon, and this carbon is bonded to 3 carbons. So we know it is a tertiary alcohol. So it's very important for you to be able to identify your primary, secondary, and tertiary alcohols, to be able to name them as well. I can't possibly do everything. This is just the tip of the iceberg, but the rules are pretty much consistent in terms of IUPAC naming. And yes, this actually brings us to the end of this lesson. Let me check. So this brings us to the end of this lesson, and I'm trying to see what is it that the next lesson is actually going to focus on carboxylic acids as well as esters.